Hello! Welcome! Today I'm gonna show you how to use this module for the science subject for all grade 7 students. So to better understand this video, stay with me. So we have here the page 2 of your module where you can see all the details about the people who are behind in making this module. So you have there the writer, the editor, the reviewer, illustrator, layout artist, and the management team, and the rest of them. And we have here the page 3 of your module, which is the introductory message, which is I'm gonna read it to you. So for the facilitator, this self-learning module, or SLM as being shortcut, is a standalone resource material in science which is intended for the learners of the Division of Bacolod City. Learners who do not have online accessibility or who do not want to risk face-to-face learning may utilize this module. This includes a learner-friendly pre-test, self-check exercises, and other modes of instructions for learners and teachers who are geographically remote from each other. This covers topics in grade 7 in the first quarter with corresponding activities for learners to achieve the most essential learning competencies and lesson objectives. Each exercise in this module is designed for independent learning and practice. However, ensure that the learner's parents, elder siblings, guardians, or relatives at home will guide and support them as they accomplish the given task. Furthermore, explain to students that taking the test diligently will allow them to learn their lessons for their academic progress. Most importantly, remind them to answer the given activities on a separate answer sheet and handle this module with utmost care. And for the learner, this self-learning module is a learner-friendly resource material in science which is specifically designed for your learning needs and progress. Your patience and dedication in reading and answering the exercises will help you successfully achieve the objectives. You are free to ask assistance from your teachers, parents, siblings, friends, and family members whom you think can help you the best. Read each lesson carefully and follow the instructions for your activities. Remember to answer the given exercises in a separate sheet of paper. When you are done, kindly submit it to your teacher, who will check and evaluate your level of competency. You can do it. Good luck and God bless.
So let's go with the page 4. We have there the parts of the self-learning module. Oh, wait. Let me change my voice. Here we go.
Okay, it's back. The following are the parts of this module that will help you finish your task. Read the following descriptions below to better understand each part. So we have there, I need to know. This part will be your guide to learn in the specific lesson, specifically your skills and competencies. I will check on this. Now, this contains a 10-item pre-test that will check what you already know. Lesson overview. This section will give you the topic information and concepts as a brief discussion for you to learn. I will do this. It is in this part that the new lesson will be introduced to you in different ways. A story, a poem, a problem opener, an activity, or a situation. You will be given specific instructions on how to go about the activity. I learned this. This part helps you generalize your understanding of the concepts. This includes a short fill-in-the-blank summary of the topic. I practiced this. This provides you with questions and exercises to help you deepen your understanding of the concept. I apply this. This section includes activities or exercises that will help you apply your knowledge into real-life situations. I test myself. This is composed of 10-item exercises to assess if you have attained the learning competencies. And we have there the references. This is a list of all sources used in developing this module. On page number 5 of your module, we have there, I need to know. This module was designed and written with you in mind. It is here to help you describe the components of scientific investigation. The scope of this module allows you to use it in many different learning situations. The language used recognizes the diverse vocabulary levels of students. The lessons are arranged to follow the standard sequence of the course, but the order in which you read them can be changed to correspond with the textbook you are now using. This module is divided into the following lessons. Lesson 1, which is the scientific method, and after going through this module, you are expected to: number 1, describe the parts of the scientific method. Number 2, perform activities that apply the scientific method. And number 3, conduct a simple investigation. On page number 6 of your module, you have there, I will check on this. So this contains a 10-item pre-test that will check what you already know. So read each sentence carefully, select the letter of the best answer, and take your time to answer all these questions. And remember, you have to use a separate answer sheet.
Have you ever had a question about the world? Like what plants need to grow? Or how to blow bigger bubbles? There is a way to find the answer to these and other questions that is used by scientists. It is called the scientific method. If you use it, you can be a scientist too.
The scientific method is an organized way to answer questions and solve problems.
The scientific method goes step by step. The scientific method, you experiment. You start with a question, try to find a solution. The scientific method, this is how you do it.
Anyone can think like a scientist by using the scientific method.
ASI, TCI, then state your conclusion. This is the science method. Everyone can use it. ASI, TCI, then state your conclusion. You start with a problem, then end with a solution. For ask a question. S for state, state your hypothesis. I for identify, identify the variables. T for test, test your hypothesis. C for collect, collect your data. I for interpret, interpret your data. S for state, state your conclusion. The scientific method, go step by step. The scientific method, you experiment. You start with a question, try to find a solution. The scientific method, this is how you do it.
Thomas Edison used the scientific method to make important discoveries about the light bulb.
ASI, TCI, then state your conclusion. This is the science method. Everyone can use it. ASI, TCI, then state your conclusion. You start with a problem, then end with a solution.
Sir Isaac Newton used the scientific method to make discoveries about the laws of gravity.
A for ask, S for state, I for identify, T for test, C for collect, I for interpret, S for state, state your conclusion. ASI, TCI, then state your conclusion. This is the science method. Everyone can use it. ASI, TCI, then state your conclusion. You start with a problem, then end with a solution. ASI, TCI, you got it? ASI, TCI, that's it. The scientific method,
Go step by step.
it works. The scientific method,
You experiment.
yeah. The scientific method, go step by step.
Aha! Now you've got it.
Moving on to page number 8 as we dig deeper to our lesson number 1, scientific method. Oh, excuse my head. So we go with the lesson overview. In life, we are often faced with questions and problems. We answer and solve this by thinking critically or trying out something to solve it. We may not know it, but we are already doing the steps of investigation. In science, there are steps being followed in doing the experiment called scientific method. The scientific method is an organized process used by workers in science and technology to solve problems, answer questions, and make discoveries. The process includes the following steps: making observations, asking questions, formulating hypotheses, conducting experiment and collecting data, analyzing result, and drawing conclusion, and then reporting of result. Now, I'm gonna show you the flow of scientific method, which is the first thing to do is make an observation. Next is identify the problem. Next, you're gonna formulate a hypothesis, and then conduct experiment and collect data. And then you do the analysis of results and draw conclusions. And then after that, you will know if your hypothesis is true or is it gonna be false. And then once you have proven, then you can go with the report of results. Now, to better understand this, let me show you something.
I know that magnets attract metal objects. I'm just not sure what kind of metal objects stick to magnets. That's cheating, Moby. We should do an experiment to find out what really sticks. Wait, we can't just start doing an experiment. What is the scientific method? The scientific method is a set of steps that scientists follow to test their ideas. The first step is to make observations and think of a question we want to ask. I've seen magnets attracted to metal objects like refrigerators, cans, and cars. So my question is, do magnets attract all metal objects? The second step is to make a hypothesis. Thanks, Moby. When you make a hypothesis, you use what you know to make a prediction. Let's see. Refrigerators, cans, and cars are all metal. So I hypothesize that magnets attract all metal things. Now the next step is to do the experiment and test our hypothesis. But how do you do an experiment? First, we need to plan our experiment. We're going to put different metal objects near the magnet and see if they all stick. Now we have to gather our materials. We have to test all of the objects in exactly the same way so we can get accurate results. Oh, right. We should be recording this. How can you record data? Data is information that you can record, like what you observed during an experiment. We can make a chart to record which metal objects the magnet attracts. Thanks, Moby. The magnet attracted the paperclip, nail, fork, and thumbtack. It did not attract the coins, keys, copper pot, or gold ring, but they're made of metal. Are you sure, Moby? I guess our hypothesis was not correct. But we still learned something. How do you draw a conclusion? The next step of the scientific method is to look at your data and draw a conclusion. Let's see. The magnet attracted some metal objects, but not all of them. The objects it attracted are made of iron or steel. Right. I guess those objects are made of metals that magnets do not attract. Like the coin is made of copper and the key is made of brass. My conclusion is that magnets only attract metal objects made of iron or steel. The last step of the scientific method is to share what you learned. I can't wait to show our experiment to the rest of the class. With the scientific method, we can keep testing all kinds of metal objects. What should we test now, Moby? I guess magnets attract robots.
There you go. I hope you enjoyed the video, and I hope you learned something from it. If you want, you can always do a replay to watch that video again. But anyway, let's dig deeper about the steps of scientific method, and let's go with observation, which is the first step. So it is a statement, remark, or comment based on something what has observed, seen, touched, or felt, heard, or noticed. Well, as you can see, observation consists of receiving knowledge of the outside world through our senses, or recording information using scientific tools and instruments. Any data recorded during an experiment can be called an observation. Examples. A scientist looking at a chemical reaction in an experiment. That is an observation. Another example is a doctor watching a patient after administering an injection. So that is also observation. And another example is an astronomer looking at the night sky and recording data regarding the movement and brightness of the objects he sees. So those are examples of observation. Second, we have identified the problem. The analysis of a situation by observation which answers to a question. And then third, we have to formulate a hypothesis. It is simply an educated guess to answer the problems based on the relationship between identified variables, the independent variable and the dependent variable. In a scientific investigation, there are three variables. First, the independent variable, which is the cause of the change. Second, the dependent variable, which is the effect or thing that is changed. And then third, the controlled variable, which is constant or not changed. Now, I'm going to show you an illustration to better understand or to give you examples about this dependent variable, independent, and controlled variable. Now, based on the illustration, you can see there we have the sun, we have two plants, and then we water the plants, and then we have there some sort of meter or like a meter stick or a tape measure which measures the height of the plant. Now, let's go with the dependent variable. It says here that the dependent variable here is the height of plants. It's because when we talk about dependent variable, it is something that is being changed, the effect. And then the independent variable, we have there the oregano extract. Because when we say independent variable, it is the cause of the change. So what is the reason why the plant grows taller compared to the other plant? So maybe it's because of the oregano extract. So that is our independent variable. Now, we have controlled variable, which is the sun and size of the pots. So we can control the light of the sun, and because we can keep the plant, it could be indoors or outside the house, so that's why we can control it. And then the size of the pots, we can also control that in such a way that we can choose a smaller or a larger pot for that specific plant. So, you know, to better understand all this type of variable, let me show you something.
So there's three different types of variables that we need to be aware of. We have independent variables, dependent variables, as well as controlled or constants as variables. So an independent variable is going to be what you will change in an experiment. So in this example here, my independent variable, since I'm curious, well, how does light affect plant growth? Well, as the researcher, I'm going to change the different amounts of light. So here, my different amounts of light, would be my independent variable. So plant 3 over here is getting the least amount. Now my dependent variable is what I observe or what I measure. So what data am I going to gather here? I'm going to measure the height of the plants because I'm curious, how does light affect plant growth? So the height of each plant would be my dependent variable. And then my controlled or my constants are the factors I keep the same. So in this example here, things that I want to keep all the same is basically everything except for the distance. So I want to make sure the amount of soil they receive, the nutrients in the soil, I water them all exactly the same. I'm using the same type of plant, so I know they all grow at the same rate. I'm using the same size of pot, etc. Anything that could influence your results, besides light, you want to keep the same. Because let's pretend that I forgot to water plant number 3. Well then, how do I know? Is it because lack of water or is it because lack of light? Right? You only want to change one variable. Now some key things to keep in mind when doing an experiment is right here I only have 3 plants. It would be better if I had a lot of plants, like a lot lined up near the window, and then a lot of plant number 2 distance, and then a lot of plant number 3 distance. Because the larger your sample size, the more accurate your data, the more reliable it is. Kind of like reviews on Amazon. The more reviews something has, the more accurate that feedback is. So you want to have a large sample size, and then it'd be good for repeatability. Do the experiment again and repeat it over and over, and then you have nice, solid conclusions that you can draw based on your data.
And I hope you understand what is variable or the 3 types of variable. Hope you understand that from the video. So moving on, we have number 4, conduct experiment and gather data. A plan consists of an outline of a procedure used to test the hypothesis or conduct of experiment. The data is obtained and recorded.
When designing an experiment, you must be sure to only test one thing at once. You can do this by making sure to only change one thing or variable in each experiment. Everything else must remain the same. Once you have completed your experiment, analyze your data.
Once you have completed the experiment, analyze the data. So, number 5, analysis of data and draw conclusion. The analysis of result based on the data gathered to answer the problem. The conclusion may accept or reject the hypothesis.
To do this, you will look at the results of your experiment and try to figure out what it means. Finally, using your data, you can draw a conclusion. If your conclusion did not support or agree with your hypothesis, that's okay. It doesn't mean it was a bad experiment. Using the information from your first experiment, you may need to form a new hypothesis and create a new experiment to test it. Even if your conclusion does support your hypothesis, you may have a new question you'd like to test and can begin the scientific process all over again.
Number 6, report of results. The communication of the results of the scientific investigation to the community. That means you can share whatever result you have, but it's all up to you. And number 7, iteration. It is the repetition of a process in order to generate a sequence of outcomes. So those are the steps in doing the scientific, or the steps of scientific method.
The scientific investigation involves the use of different science process skills. So this time, we will be talking about science process skills. So these are the basic skills used in experiments or solving problems. Now, these include the following actions, in no particular order, of course. So we have observing, communicating, classifying, measuring, inferring, and predicting. Now let's dig deeper about observing. So this is the most basic skill in science. Observations are made by using the five senses. So, good observations are essential in learning the other science process skills. So, for example, the learner will be blindfolded and make observations using the sense of touch. So, that is an observation because you will be using one of your senses. And another example, the learner will create observations about a coin using the five senses. And another example is the learner will mix primary colors to create more colors. So that is also observation or observing. Next is we have the what we call classifying. After making observations, or let's say classifying is grouping the objects or situations together based on their attributes. Meaning to say, after making observations, it is important to notice similarities, differences, and group objects according to a purpose. It is important to create order to help comprehend the number of objects, events, and living things in the world. For example, the learner will use a magnet to classify objects as magnetic or non-magnetic. So, he will be doing a classification between magnetic or non-magnetic. Another example is learner will combine different liquids with water to determine which is more or less dense. So those are examples of classifying. Also, we have what we call another science process skill is measuring. It is a quantitative way of expressing physical characteristics. So that means measuring is important in collecting, comparing, and interpreting data. It helps us classify and communicate with others. The metric system should be used to help understand the scientific world. Now, let me give you an example. Let's say the learner will find the mass of different liquids that have the same volume. Meaning, we have a liquid with the same amount of water, but when we measure it, we will get different weight for each of these sample liquids because they are different from each other. So that is measuring. We are trying to measure the mass or the weight of that specific liquid. Another example is that when the learner will use technology to find the speed of a toy truck. So it's still measuring because you will be measuring the speed, how fast the truck can go by using a technology or by calculating it. Another example is when the learner will measure the distance of a marble that travels, when you play with it. Or let's say the learner will measure the length of a crayon or a pencil. So, also we have another science process skill, which is communicating. It is reporting or sharing what has expressing physical characteristics. Well, let's say it is important to be able to share our experiences. This can be done with graphs, diagrams, maps, and spoken word. Example, the learner will create a line graph showing the relationship between speed and the mass of a car, a marble, or any moving object. So that's communicating. Another example is when the learner will discuss possible error with other classmates. So that is sharing, and that is communicating. Next, we have also what we call inferring as also one of the science process skill. So when we say inferring, means explaining or making assumptions out of observations, experiences, and prior knowledge. So an inference is an explanation based on an observation. It is a link between what is observed and what is already known. For example, the learner will infer, or the learner will say, oh, it's going to rain because I can see darkness in the sky. So the clouds are dark. So the student will infer that it's gonna rain. And another example is the learner will create inferences about observations they made about a mystery object. So the learner can say, I infer it is solid rather than hollow. So that is in. And also the last that we have for science process skill is predicting. It involves finding patterns, and it also uses experiences to form a hypothesis. Questions like, what do you think will happen? It is an educated guess based on good observations and inferences about an observed event or a prior knowledge. So for example, a student will predict what is a box based on observations using the sense of touch. So that is predicting. And alright, that's it. So moving on to the next page, which we have the part which says, I will do this. So this is your part. This is gonna be your first activity. So the activity number 1, entitled My Graphic Scientific Investigation. So the objective for this is you have to make a graphic scientific investigation using simple problems found at home. So you need to study the illustration and read the notes below, because as you can see on the screen, that's how you should do it. Your illustration. So you're gonna make an observation, you're gonna ask a question, propose a hypothesis, test the hypothesis, you do the analysis and conclusion, you report, and then you iterate. So make sure to read the notes below. Okay? And for the materials that you're going to use for the I will do this part is, or are, activity sheet, your bond paper, and of course your pen. So remember, you really have to have a separate answer sheet to give your answers. Okay? And then the procedure. I'm gonna read the scenario to you. So here it is. During the rainy season, the mosquito population is rising. What could have caused the increase in their number? So based on the scenario above, make a scientific investigation applying the steps of the scientific method. So we have here a ready-made box for you to answer, but you have to copy this on a separate answer sheet. Okay, so we have science investigation process. So you have there observation, the problem, hypothesis, experiment. So you're gonna discuss the steps you did to test your hypothesis, okay? And then you have also data analysis of results and your conclusion. So it could be accepted or rejected for your hypothesis. And then once you're done with that, you may proceed with the next part, which is I learned this. On this part, you're gonna give your answer and you're gonna use again a separate answer sheet. So the first part that you have to answer is you have to fill in the blanks. You have to select your answer from the word box. So you have there the choices. You have prediction, you have science process skills, iterate, you have identifying problem, and then you have the scientific method. You just have to read carefully the paragraph, and then you have to give the answer, or you have to fill in the blank with the correct answer. Alright, and then for the part B, it's some kind of enumeration. So again, it's gonna be, you must have a separate answer sheet for this. So you have there the questions, what are the steps in the scientific method? So you have to give all those steps. And then on the letter C part, the question is, what are the different science process skills? So it's still enumeration. So you're gonna give all those science process skills. And I know that you already know all the answers for this, as they are already discussed, right? Okay. So once you're done giving your answers on this, you may proceed with the next part. I practice this. So you're going to identify the steps of the scientific method in the following situations below. Choose from the option inside the box. Again, you have to choose the answer from the box. So you have there, the choices are identify the problem, make an observation, formulating hypothesis, conduct experiment and collection of data. You have also analysis of result and then reporting of results. Now you have there two columns. You have the first column for activity. We gave you 6 sentences, so you just have to read each one of those, and then you're gonna give your answer on the other column, which is the steps in scientific method. So for example, number 1, Lani thought of putting one of the indoor plants outside while retaining the other inside her house. So based on this statement, you have to identify what steps in scientific method is being applied. So you're going to choose your answer on the box above. Okay, same goes with the rest of the number. And once you are good with this part, you may proceed with the next part, which is I apply this. So you're going to choose a spot in your house, observe that spot, and pose a question that could be a good problem. Review activity number 1, which is my graphic scientific investigation. You have to use separate paper for your answer following the template below as your guide. So the template below is, you have the science investigation process, you have the observation, problem, hypothesis, experiment, and then you have the data analysis of result and then the conclusion. And for the last part, which is your post test, so you're going to test yourself. So it's still multiple choice with 5 items. So you just have to give your answer, but you have to read each item carefully before you give the best answer. So you just have to choose the letter of your answer. And for the last page of this module, you have there the references. And that's it. So thank you again for watching the whole video. I hope to see you again on my next video. You guys have a great day.